Moving to the next presentation, in a world where we are surrounded by tons of data churning valuable information, somewhere along the way, the very essential element of experience is getting sacrificed. This is a perspective to make data deliver the experience in a connected world. From behavioral analysis to microservices, leading to wow experiences for every stakeholder in the value chain. May I now invite Mr. Venugopal Subbarao, Senior Director and Head Solution Consulting, ServiceNow, for a session on Variance2Experience, a prescriptive data model approach. Round of applause, everyone. Thank you so much.
Thank you, Gaurav. Thank you. Okay, the other side. Thank you very much, and Gaurav, and a very good afternoon to all of you. I'm Venu. I lead the solution consulting for ServiceNow. How many of you know ServiceNow in this hall here? Wow, that's amazing. Thank you, Dr. Suresh. I think if I Google USG and ServiceNow, a case study, you would see that how the doctors have been able to transition their work towards analytics, AI-based abilities, and giving more time to the doctors to do the core work. And as well, the pharmacies and pharmacy division of theirs in terms of how fraud and everything has been able to manage significantly. And that's about ServiceNow. This is publicly available information. But I understand that you've been waiting after lunchtime, and I saw Gaurav telling about, is it lunchtime? And I can remember one, on the lighter note, an ad of Cult Fit saying that it is a statutory warning, sitting is the new smoking. And after that, there was you know what would have happened in the hall. So with that note, I would start saying that today I wanted to talk about a topic called variance to experience. Why did I choose variance? I wanted to put it as a data to experience in many ways, because at the end of the day, it is this data that is going to become an experience. But I choose variance for a purpose. Variance for a purpose because that also reflects me on my background that I come from. I started my career in a company called Caterpillar, an earth-moving company which is advanced in automobile technologies, made by hydraulics, pneumatics, electrical. It's far advanced during those times when I started my career in 90s. And if we have to do in those times, it is about going through those statistics played a very important role in understanding, in shaping my career during those times, may it be around batch productions, giving a moving average model towards batch production, defining a statistics process to it, or towards doing an analysis of variance towards different parameters that affect. For example, an adhesive and a brake shoe. How does a temperature define the adhesive capability into a brake shoe? These are some of the things that we studied and come, and at this point of a time when I interact with some of these companies, go back to the memory lane. But variance plays an important role. Why does variance play an important role? Is because variance exists everywhere. For some problem to be defined, we want to find a solution, and a solution is always comes from some technology. And technologies you would find in different ways. And technology silos starts to happen. A technology silo could be, I want to do something around chat, and you acquire a chat, and you increase to a chat sprawl. I wanted to do a mobile, and you increase the mobile sprawl. And similarly, the technology sprawl starts to move and starts to get into the organization. The second is about process sprawl itself. The process sprawl is about defining the complexity of process that we want to ensure that the experience remains the same. Last but not least, the business itself. There's the definition of business, what it demands, but at the end of the day, if you look back, the kind of complexity that you have created out is churning tons of data, and this is causing variance. Now this variance, wherever there is variable, there is going to be variance, but this variance, the variable to variance transformation is where the entire story begins. And story begins because I wanted to define what variance is. If you see, variance is a measure of dispersion, and we know that in a language of Six Sigma also, the variance defines your variable, and the variable is about how closer you come. How do you define this variance closer so that you can be able to predict things? So the lesser the variance, you are able to predict better and better, or observe those variance, you are able to predict in more and better and better. So this is significant in terms of what does a variable and variance cause. And if you are able to study the variable in much more defined manner, then you are able to evolve solutions out of it. It could be a healthcare solution, it could be an automobile solution, it could be any industry solution for that matter, but these solutions have to create a greater experience. Data will remain, data will convert it into models, and models will be converted for testings, and these tested models can be put into use. And for what? For that experience. These experiences define in terms of what we touch and feel. And these experiences are going to stay forever. It could be a patient experience when we go to an hospital, as Dr. Suresh was mentioning. Or it could be an automobile experience as we touch this steering wheel or sit in this chauffeur-driven car. Those experiences matter. So how do we convert these data into experiences? These data are converted because there exists certain process. And these processes are run mechanically behind the scenes that we are not observing. Behind the scenes, there is a starting point, there are touch points. These touch points get into different areas in terms of an approval process involved, an initiation process at some times, a document be created, a digital signature on some point, but being able to convert these things, there are from initiation to determining to assigning, and I'm talking about an example now, but wherever these touch points are involved, there is a technology involved, a technology of virtual agent, a chatbot that is coming and conversing with that. An employee-related conversation could be specific towards an employee asking for something and responding to that the virtual agent is able to converse, or from a customer point of view, you're asking about a problem to be defined and a problem need to solve, a credit card lost, or a parts not received from a B2B customer from an OEM point of view. How those conversations happen, how does that search for a part happen and get that parts being delivered, or whatever that transaction may be. So you see that there is a virtual agent on one part, there is an artificial intelligence and machine learning working together to make this process work together to make those outcomes possible. In these areas that you see here, from right of information collected to categorization, to reassignment, to resolution, to completion, and predictability, there is a complete process involved. Behind this process, these data is talking to themselves in terms of what somebody wants. And these are experiences at an outcome point of view. An experience, when we say that if I am looking at a chatbot, there is an experience because now I have not touched a human now, but that's where I am able to converse this and close it without any interference. For somebody, I'm trying to pour emotions into the other person. I was into one of the logistics company, and they had named their team of customer service as called as anger management, because the customers were pouring anger in terms of parts not received, things not received, like that. So it was different. It is painful for somebody to be in that organization or to observe those people having that named in such a manner. That's not what they are supposed to do. So how do we convert that in doing a better job is an experience. And similarly, there are certain areas, and what you would also see that in the entire process of from A to B, from starting to finish, there is an auditability and transparency required. Most of the industries, and I have seen from then to now, the Indian companies have become much more transparent, much more regulator facing in a transparent manner and collaborative towards that. How do we ensure that every touch point that we have has a complete visibility towards every process to the regulator or the internal audits that are there? What you see here is the ability of that. Even at a document management point of view, if there is a field that is there, take for example an Aadhaar card, and we are talking about a first name and a surname or a middle name put together, and this document itself, what is the technology of AI/ML? And I was talking to a data scientist the other day. He was saying there is nothing called AI/ML, Venu. It is only either it's a basic learning or it's a deep learning. Now, if it's a basic learning, what is a basic learning all about? Basic learning is to do ensuring that putting through a certain data and telling that there is an outlier, work on the basic data, and you would find an outcome. A deep learning is to do a deeper study where the data is not classified. We have seen shift left. We're shift left in terms of, in an automation language, how do we convert the work that is there to moving towards self-service? In the data language of shift left is those unstructured data into a structured format is a shift left. Now shift lefting means what happens to the structured data? Structured data has the ability to add values to it, add tags to it, and more predictability to it. At the end of the day, we want predictability to whatever we are doing. So between machine learning and basic learning, you would see these data being analyzed. So if I'm asking a person, how do you define a dog or a cat? So dog or a cat can be defined if I'm asking a human to be answered, and I would say, oh, it looks like a brownish color, and the ears are like this, the eye color, and things like that. But the machine would read in terms of the distance between the eyes, the texture of the skin, the texture of the hair, the density of the hair, the boundary of a cat and the dog. So these are the parameters that the machine sees. And what are we able to do that with that information? With that information, if I am walking through an airport and seeing that if I'm walking through a shop and I am walking through that and I saw a watch that is amazing and I look at it for 2 minutes, this I'm capturing is able to see my eyes and hold on to that. If I am holding on to the 2 minute extra ability to capture that data and create that data and meaning out of it and provide an opportunity for that businessman to do what next for the same person again when he comes to the airport, or for a different person with a similar kind of an eye movement. And the important point is about capturing that eye movement. You and I cannot do that. Machines can do that. And that's where the whole opportunity here using these kind of machine learning capabilities put into our businesses. Next, I want to reflect in terms of what happens because of that. I'm going to give an example. When I talked about a cat and a dog, it's the same thing about a document also. Now in a document also, if I want to automate or digitize a document, if I'm able to understand the boundary conditions of the document and ensure that these are the sum A, B, C, D, E, and at the sum total and the grand total, this machine is able to understand that there is a field, there is a space to the field, and after this couple of spaces, there is going to be a total around it. And if there is any change to these fields, it immediately recognizes and holds on to this memory. And memory is about having a trail. Audit trail of the document changes that is going to. It could be an Aadhaar card or a PAN card that has evolved from years to years, or even our gate entry document that has been automated. Some of the new inclusions that may come in, a COVID positive, a vaccination certificate been included. These inclusions are subject to audit trails in some of the regulated industries. So are these inclusions added, and do we have an audit trail for the same? So these are document management systems around how we manage these things. So these are some of the examples around it. I want to just step back in terms of, if I want to talk about, I talked about customer behavior, I talked about, for example, I can also talk about an employee. If I want to hire a person between this age group and this experience, what would be the typical salary? Or what is the probability of this person having this salary with this experience and this gender, what is the probability of that person joining? So these are some of the possibilities that you can do with inverse of data and algorithms. So next is about the service operations. The service operation is an interesting paradigm here. How do I ensure that this left part is the, and I touched upon this in terms of how do I shift left, I said virtual agents and AI search. Now I will just go deeper in the context of what I mean in going into search and other areas. But the context is in terms of how do we provide the front-ending part in terms of providing information that is required for us when we want something is what you see here. And when we are doing that, how do we ensure that we are providing this functionality of classification, similarity, clustering, regression, all these statistical terms put into one box to make that happen. When we go and position this to customer to solve a problem, we solve saying that, hey, we have correlation, we have capabilities to correlation. So what does it mean? We can do clustering, we do all these things. So what does it do is the most important thing. So what does it move? It moves from tickets to services, routes alerts, identify automation, predict changes, and then in the automation side you see fingerprint matching, health log analytics, predict issues, log analytics, and all those things. But what does it actually do is the science behind it. And I wanted to reflect on that science for a moment. I wanted to talk about some of the areas about how this has been made. While we know that there exists in terms of what are the use cases that we are able to derive. The how part is very important. While everybody can talk about a correlation that is happening, a correlation is a deep science that is involved, a deep statistics involved. For me, statistics has been a passion. Back in those days when I used to start knocking the doors of Indian Statistical Institute and learning from those professors in terms of what is the best model to be applied, has always been my curiosity to drive in those days itself. Now it's just accelerated that pace because the power to observe for certain things are more and more. And as we meet more and more use cases, we say we are getting hungry to solve those problems. What you see here is some of these things like aggregation. Aggregation is basically to try and bring a group of things together. If I bring the group of things together, a CI grouping that is coming, a configurable item, and or multiple alerts coming to one CI. So these are the concept that you see that if a service is going to break down, how are you able to predict that? If you will be able to predict only if this grouping is happening. So aggregation is one statistical tool or an algorithm that goes behind in making that possible of grouping those CIs and bringing those alerts or a series of alerts coming into one particular CI. Clustering is one other important thing because it removes this in terms of bringing the like-minded similarities into one single group so that you are able to observe the changes happening there. Clustering can be done and then you could do a regression analysis around it and you can actually find the distance of error between the straight line. Anomaly detection is another thing that I wanted to talk is in terms of if there is, when you're doing a clustering analysis, you would find certain data going outside the collection of data. Now these are called outliers. Anomaly detection needs to understand that where do I take this data. As I told you, these data that this machine is trying to learn is from a graph of space, and the space is measured in terms of how in an XY axis in a two-dimensional space and in three-dimensional, four-dimensional space. Most importantly, it is this matrix that is being converted from rows and columns, trying to between where exactly this particular location stands. And that's where you are able to understand whether to take that particular outlier or include that outlier into the system and convert it for decision making. Imagine these systems that are there are used for decision making. This decision making, as Dr. Suresh was mentioning, the healthcare systems are so advanced that you can find about a particular disease looking at the data point. Looking at the data point, the clustering of the data, and tell whether this will impact it now, then, later. If you are able to predict in human health systems to that extent, and you are able to talk about the driverless cars, there's going to be significant decision making that is there. Things like temporal correlation. Temporal correlation, I told you about certain areas in terms of image processing. We are able to catch an image, and I'm passing through an airport I mentioned, and if you are able to capture this image, the eye, and I say that if I want to make a person donate, I am able to show certain figures, certain crying faces, that I get emotional, I connect, I stand for 2 minutes. And I mean that I am connected with that. And this machine is able to see that connection happening, and it tries to say that my image processing, it can find out who I am, the passenger, and it can probably give me that next time I am being contacted to make that possibility happen. So these are all temporal correlation is about those image processing, to what extent that image can be processed, to the density of that image, to bringing that scaling of that image itself. Now, click graph is also a relationship in terms of how the pathway happens. Click graph in many terms, it's called the family system technology. In a family, you have parents, mother, father, sons, children, sisters, brothers. To what level of relationship is this going to be important for us? These are called nodes, nodal relationships. This nodal relationship plays an important role as we design systems for IT or OT systems we call, between a service to a load balancer to firewall to the servers. That is one level of systems. And in the OT systems, you can find that location to a machine to a assembly, sub-assembly component, subcomponent, the subcomponent is associated to somewhere else. So these are the kind of associations we can do. But to what level of triple click or double nodal, triple nodal, 18 nodes, whatever loads. So if you see that in our own personal lives, what level of relevance is our generation relevant to me, the past generations, the second generation, third generation. Probably after 3-4 generations, you wouldn't know that the relevance of it. Probably you wouldn't even know who the fourth generation is itself. So that's the kind of relevance that we need to decide upon, or the system needs to decide to what is applicable for this particular scenario, to what level of depth is required. So click graphs provides that opportunity to do so. Now, regression is a tool that is used for deep learning. It is a regression. You can have many types of regressions. Basically, it is about storing those scatter of data in a linear regression format and finding about the positive and negative correlation. The scattered data moving out of the regression line and trying to find out the nearness around it. Right fit is all about getting that right fit, but getting out of right fit is where you can see where we can move towards it. So regression plays a very important role in terms of predictions. There are logistic predictions and so many regressions analysis around it, but these are the areas that's involved in it. Bayesian theorem and cosine similarity and Chaliu is also about finding the root cause analysis. Now, if you know that there is a data, we are able to cluster the data. We are able to put the identification of image processing data, the word data. By the way, a machine doesn't understand anything other than mathematical formula. So everything, whatever we see here, is converted into a mathematical formula. And Bayesian network, cosine similarity, and Chaliu is also about finding this relevance of your position to the other position and trying to give a decision using that framework. In cosine similarity, the distance, physical distance between one data to another data could be, you call it as Euclidean, it could be far away, but the angular movement, angular distance could be far lesser. And hence the data is relevant for making a decision. So why am I saying all of these things? Why am I saying all of these things? It's because there is a purpose behind it. The purpose is about a story. The story is about, before I get into this, what I mentioned here, for example, I'm going to a Uber or a Ola, and I'm getting into a cab. What is relevant for this aggregator? There exists an aggregator who wants to generate a revenue. There is a customer. There is a partner who's a driver who is owning the car. Now, the customer behavior analysis is a very important parameter that I need to do. What kind of cars that I choose? When do I choose? How do I behave myself? What kind of stars that I have? And how do I pay? These are some of the parameters that I have. The partners in terms of what stars does he have, where does he apply, what time does it apply, and what stars does he carry from a partner point of view. And from an integrator point of view in terms of how do I find different ways of generating revenue. Is it possible that if he's a regular user, can I push him through some model where I can generate an advanced revenue model so that I have, software services company have a 3 years revenue behind them, and that's making him much more predictable as a company, and hence stocks invest onto them. And similar is the model that the aggregators want to do. Can I have a front-loaded revenue being loaded by that customer based on this behavior? Can I get this agreement from this vendor on his performance so that I can give a front-loaded partnership with this partner? These are choices that you can make. And how do you make it? Is through those statistical models that you mentioned. And each of these statistical models that I earlier told makes relevance here. In here you are talking about an IT system where there is a flood of data that is coming from different areas, from log analytics to predict issues, and then converting into different intelligent formats. Lastly, I wanted to also touch upon one important thing is about the question that was asked in terms of how do you do when multiple systems are there. The answer is very simple. I can say ServiceNow, but the point is about how do we do it is the question, is the answer. And that's where we need to work in terms of how the question is about understanding that there exists a system, there is a statistical model that operates for different persona and different storyline. And in all of these things, if it exists in one single and you have, I'm just putting the slides because we are just getting into the close of the time, and I am sensitive about it, about the time that we are running. But there is a whole lot of science about how data is captured, data is collected, the data is modeled, the model data is tested and put into a machine like this. This machine understands different industry verticals. This machine understands different experiences that is required from customers, employees, whatever could be the interactions. This machine understands how to react to certain instances, how to respond to certain instances, how to predict much before with a certain level of confidence. And that's the possibility today you have. And when we say that we are able to consolidate, reduce noise, reduce deflections, this is a possibility that ServiceNow offers. And this is about not just the data. In this platform, when we provide this platform, you can dissect into different ways. Dissect this platform into rows, and you would find one new variance that is coming. Dissect it in vertically, probably there is a tool available, you would find a variable coming in. But these variables, when dissected in a siloed manner, you would solve a problem, but not solving one problem that the enterprise wants. This is one single architecture, one single model that caters to the holistic needs of the enterprise, serving their customers and the internal employees in a single frame of modeling. And that's what I wanted to end with. One single quote is that wisdom is not experience. It's the interpretation of experience that makes the whole game work. With this, thank you very much for patiently listening to me. Any questions?
Okay, we're going to take one question. Yes, it's there. Can somebody please hand him a mic? You okay with that, sir?
Hello. Yeah, hi, sir.
Yeah, hi.
The question is regarding clubbing the data.
Your name?
Varun.
Varun.
Yeah, hi. I'm from Marsh and McLennan Group.
From?
Marsh and McLennan Group, MMC.
Okay.
So the question is regarding clubbing the data, or like you said that, structure the data. So say if I have got the incidents in ServiceNow, and I have to do a predictive analysis, or I have to do anomaly detection, but my data is very separate. My incidents are here in ServiceNow. I've got data of the major incidents in, say, on SharePoint. For servers levels, I have got different type of monitoring. Say, I have got one on Datadog or on Spectrum. On application side, I have got something called alert side. So we have got the data. But to club that data, to structure that data, to get something into meaningful interpretation, that is where we always stuck at. So how to club these different sorts of data to interpret something out of it?
I think that's an excellent question, and that's the problem that I was trying to picturize here. Due to paucity of time, I couldn't get that. But what it does is ingestion of data from multiple sources is one of them. The source is important, and we respect that source of information that's coming. But having those source, all our investment is going into building that intelligence framework, irrespective of where it is applied. It could be applied in a digital workflow, a customer workflow, an employee workflow. Ability to ingest the data and make meanings out of it and provide a predictive option, or in many cases a reactive option also. This is something that we could do. It's a good question. Our stall is just around there. We can talk deeper around it, but we'd love to thank you very much.
Thank you. Great question. Thank you, sir. May I now invite Mr. Amit Relan, Director and Co-founder mFilterit, to please felicitate. Thank you so much, Mr. Relan, Subbarao. Fabulous to have you.